My training is as a mathematician originally, and then I focused on statistics, primarily, well, graph theory, actually pure mathematics, but graph theory and multivariate analysis, ostensibly a doctorate at the University of Oxford. A lot of what I've been taught, my training, is applied mathematics. So things like calculus, optimization. And when you study a doctorate, it can be very specific if you're doing something sort of pure mathematics. But if it's sort of applied, you get a lot of things sort of converging, a lot of techniques sort of converging. And if you don't have analytic solutions, you need to do it numerically. And that's sort of my jumping off point, really, in terms of artificial intelligence. So I'm going to make the bold statement that I don't believe that artificial intelligence exists at this precise moment in time, but that's a hard definition. So that is something in silicon that behaves in much the same way as a reasonably intelligent human being. And here's the thing, in any situation. Well, that's the stuff of science fiction. There are hints at sort of generalization, but I don't know why we don't celebrate what we've built from a machine learning perspective, because we have truly fantastic automated systems. I mean, we fly helicopters, planes by wire, etc. These are very good machine learning systems. They're often using fuzzy logic, if you want a specific type of technique that's used. But it doesn't have to be artificial intelligence. At the end of the day, we're still dealing with our most reliable type of computing is binary computing, zeros and ones. So I need to, whatever my problem is, I need to take the input and I need to turn that into zeros and ones in some way. And that's how I do the computation. It is quite wonderful what we have in our armory, the sort of chip design, etc., the sort of power, the data. We can do some fantastic things, but all of this is based on some fundamental developments as human beings. I mean, we can go back to the ancient Egyptians. They were using calculus. With no calculus, there's no large language model. I've left out a lot in between. But primarily, that's what we're talking about. It's good old-fashioned mathematics. So math stats, add a bit of coding. That's really what AI is today.
It's very interesting to talk about this concept, right? And I'm afraid we might still have to speak of it as AI for short through the interview because I'm so used to it.
That's fine. We will play the game.
Yes, but I think, it's very good to go back to those fundamentals. And there's been a time when we're talking about machine learning and then different types, reinforcement learning, etc. And there was a tipping point when OpenAI introduced ChatGPT and we managed to all experience this, which I think has been a transformative experience. And since then, we've opened the gate and it's all AI. Maybe we can go back to this ChatGPT and understand really what happened there. And I think what's interesting, again, from an outsider point of view, is that, suddenly there was this thing and we thought, this is groundbreaking. And 2 months later, everybody's doing it or a different version. So what happened at this particular point?
Well, I mean, ChatGPT is essentially involved in word prediction. Okay? This is highly statistical. I mean, a very good example is just a simple bigram model for words, whereby I look at pairs of letters in combination, and what you find is that we take a language, any language, it works with any language, but let's take English, for example, and I look at pair combinations. Certain pairs occur very frequently, others less so, and some not at all. Well, if I can do that, I can count those pairs in terms of a corpus. We talk about corpus, a body of data. If I can do that, I can imagine if we've just got lowercase Latin letters, I can imagine a 26 by 26 grid. I can then turn those into probabilities. So I can normalize by the rows, turn them into probabilities. Well, you see where I'm going with this. I've immediately got a model. It implies a statistical model. I can fit the distribution to those individual rows. So that might be a multinomial distribution, perfectly reasonable distribution for discrete data. Well, if I can do that, then I can fit a model. I can write down a likelihood. I can write down a function and try and maximize that function to get the parameters out, taking it a stage further. If I have that, then I have an idea of loss. And if I've got an idea of loss, then I can fit a neural network. Now, I won't take you through all the stages, but essentially that is what is going on. And everybody is doing the same thing. So what I'm doing is I'm fitting a neural network to data, text data, but of course I've turned it into numbers. I can only compute with the numbers. There are some other important facets of this sort of design in terms of what neural network architecture do I use. I'm probably going to use transformer, which is a particularly effective type of neural network. I'm going to use the attention mechanism, Vaswani et al. 2017, which is actually just a nice piece of linear algebra that allows me to cut down on the computation, and actually was really invented originally for language translation, so English to French, so on and so forth. It just so happens that if I use enough parameters, 80 billion parameters, and I've got a large amount of data, 4.6 terabytes of the internet, I can actually build a pretty effective large language model. This thing is incredibly good at fooling the user into believing that they're interacting with a human being. But actually, it's completely dumb. It's got no cognizance whatsoever. It's not sentient in any way, shape or form. Don't be fooled by any sort of computer scientist who suddenly thinks there's a ghost in the machine. It is remarkable that it is able to generate words, sentences, paragraphs, coherent streams of seemingly meaningful output. But essentially, it's good old-fashioned probability and statistics. It's doing it completely probabilistically based on what it has ingested. And I started with a bigram model. Of course, we can extend that. But essentially, that's what's going on. So data, a corpus, and I can choose anything. And obviously, my large language model will depend on the quality of the data and the type of data that I feed in. I turn that into numbers. I fit a neural network. I use my transformer architecture. I use my attention mechanism. And essentially, I can build a large language model.
Well, fascinating. That's really an interesting perspective. And also a very interesting experiment is that we are actually confused that this looks like, if I refer back to the human experience of learning, as I have small kids, it's about we'll learn whatever the grammar, the vocabulary, and then it all comes together. What you're saying, well, is completely different. And yet, there's been this tipping point where we could have experienced this, let's say, confusing experience a couple of years ago. So why did it happen then? I mean, is it because suddenly those models have been able to feed on so much data, or is it because of the computing power, or is it a mix of all this?
Well, it's a mix of data and computing power. So these things have come together. The actual sort of model development, if we say that the transformer has been transformative, there's been less of that, as it were. That's been very incremental. It's still based on good old-fashioned fundamental concepts in statistics, mathematics. And so that's really what's come together to allow us to develop these type of models, which are, if you're technically minded, they're over-parameterized. So, many, many parameters. Coming back to an earlier point, we tend to sort of anthropomorphize these things. So you mentioned your son or daughter learning language. And how do they learn? Well, they learn by imitation, and they won't necessarily, they'll learn formally later. But essentially, there's an awful lot of imitation there. They're sort of ingesting it, and their brain is working in such a way that they're able to sort of reproduce, and then, of course, extrapolate from that. And we like to think that these models work in the same way. They aren't learning in that sense, or what we're doing is we are fitting parameters to existing data in this large neural network. So we're talking about fitting those weights. And, if there is an expression of learning, that's it. The mathematical, practical expression of learning in a mathematical context is actually optimization. So I'm going to move towards a solution that I think is appropriate. I set a certain criteria on what that solution looks like. It's not learning in the same sense as a human being. And the rub is that basically that this thing that has been developed really doesn't know, it has got no sense of what it is saying. It's a beautiful generator of seemingly coherent language in context, etc. But there's no ghost in the machine. There's no spark of intelligence there. It is, in many cases, it is simply reproducing information that has been encoded. It can interpolate. It can produce things that don't exist in the data set, but might be between 2 points, as it were. It can actually extrapolate. It can sort of generate new things. I mean, a classic example is just to take a US data set, baby names. So Andrej Karpathy talks about this. Andre is a neural networks guru. He's one of the co-founders of OpenAI. He worked for Tesla. He helped develop Autopilot, the driver assistance system. And he talks about this model, and basically it will generate names in a data set, but it will also invent names as well. And a lot of them are, seemingly completely nonsensical. You'd never choose certain names that the system generates for your child. But then other names they're not in the data set, but they're quite plausible. So, and I use that as an example when I sort of give a lecture on sort of unpacking large language models. And, you can get an idea of what might be going on at a larger level when I've got more data and I fit in a more sophisticated model, etc. But it's essentially the same thing. It is very clever word generation. Now, when I started programming way back in the midst of the time, I was a schoolboy and I wrote computer programs, computer games. And I thought it should be possible, decades ago, to sort of interact with the computer in the way that we've been interacting in the last couple of years. It's taken a long time to get to that point. I mean, it's really quite wonderful, and we should celebrate that fact. Yeah. But we shouldn't think that this is the spark of genius, the spark of silicon genius,
There was this Turing test.
Yeah, but that's not a formal proof, George. I mean, everyone talks about the shit, and as if it's some sort of Alan Turing was a mathematician. Turing test. It was largely a throwaway statement.
With this podcast, we think a lot about, the hype and the reality. And in fact, yes, even passing the Turing test, even if we had it as a reference, it's not, like you said, a formal proof. And another thing that I think is worth considering, how these things are presented to us, because now I understand that, yes, it's just a very clever way of guessing the numbers that transform into letters, that transform into words. Yet what we see is there's this evolution, right? We keep seeing these tests, now it's reached A levels, and now it's reached a master's level, and now PhD level, and blah, blah, blah. Is this a clever marketing ploy?
I think it is largely marketing, to be honest. The other thing is that, a lot of what we do as human beings, certainly in our working lives, tends to be quite mundane, tends to be quite repetitive, quite regimented in a way. Well, anything like that is ripe for automation. I guess, there are lots of jobs that are undertaken by white-collar workers, and they think somehow that this could never be overtaken or carried out by a machine. Well, I think actually they're in for a bit of a rude awakening, because anything that's sort of repetitive in nature is ripe for automation. What our large language models aren't going to be able to do, is, come up with a general unified theory in physics. Not with our current state of art in terms of computing. It's never going to be able to do that. There isn't that human spark of genius. And I mean, I've heard various things. I mean, there was a researcher on the radio saying, my large language model came up with these fantastic hypotheses, etc. And then when you sort of dig a little deeper, well, it's quite soft science. I think it was sort of economics, and, economists love postulating hypotheses. They're not that hard to replicate. There are some fairly straightforward sort of hypotheses that sort of recur in that sort of field. I don't want to be too rude about economists. And so for a machine to come up with these ideas, I don't see that as a great stretch. We take physics, though, that's somewhat different. I don't see the sort of spark of genius there. I use physics as a previous example. So I think we're sort of fooling ourselves in terms of examinations. You mentioned examinations. Well, a PhD is perhaps a little bit different. That's a bit of a special area. But certainly, law examinations, medical examinations, you're largely testing knowledge. So if the knowledge has been encoded, why can't a large language model, handle that? But do you want to be treated by a large language model in hospital, or do you want to be treated by a human being?
Sure. It reminds me of the wonderful book from Kasparov, where he got bitten by Deep Blue. And there's this, of course, this was before we talked about AI and all that. Actually, it's at least a few decades ago. Right? He didn't expect to be beat, and then he wanted a rematch. And, well, now computers beat the world champion.
Well, in fact, that board over there, George, that plays at 3,000 ELO. That would beat pretty much Magnus Carlsen.
And he was thinking, the chess is finished, right? The level of interest in chess, etc., is going to drop because it's not the ultimate expression of intelligence, but not at all.
No.
And chess is thriving, despite the fact that robots are much better than us.
There's even sort of competitions with using human and machine to play games. So, effectively a centaur, if you like, that combines the two. But, George, what can I say? Chess is on fire. We haven't spoken about my chess habit, but I do have a bit of a chess habit. So I captain the National Liberal Club team, I play for
Wonderful.
Oxford City, and I've just started playing for Her Majesty's Treasury because way back in the midst of time I was an intern there. I'm actually eligible to play for their team. Everyone's playing chess. I sit on the train and there's somebody next to me who's playing on chess.com. But we don't want to go down that rabbit hole.
We don't want to go there, but it's a rabbit hole that I've found myself very interested in only since a few years. I do play on chess.com, but it's a new habit, and I must say, I never thought I'd love it so much. But let's go back to now our talk about all this AI, and I think we've got a much clearer view of what it is and, then what people do with it. And now I want to go and talk a little bit about what it means in terms of finance, the economy, investment management. And what I saw, I'll go back to my anecdotal evidence from everybody's building something on AI. Of course, there's hype, right? You want to put an AI somewhere on, you have to put, say, we're investing in AI because analysts would like that. There's also teaming up with OpenAI, etc. So people can interact in a different way, but then apply it to very different types of data. And many people, what they do in finance is to restrict the field of data, to use internal data and things like that. Is this the right way to present this? Word generation capabilities that can be applied to new sets of data and develop new applications?
Yeah, I think so. I had a conversation with a medic last week in terms of putting together some sort of system for mental well-being. Obviously, there needs to be suitable disclaimers in place, but I said one could take a large language model and simply develop an app on top. Just use an API, application programming interface, and plug directly into that. In an afternoon, one could build a minimum viable product, but certainly a prototype. Going on from that, what I think you do need to do, though, is to sort of be very careful about the input. So that corpus that you use. And I think that needs to be targeted, and it needs to be appropriate for the subject in hand. So, I mean, we should talk finance, shouldn't we? So, yes, I want something that has been fed with good quality data. Bottom line. So the old adage of garbage in, garbage out is as true now as it always was. So you really want the correct corpus, as it were. Also, you want to have some guardrails around the output. Well, partly by making sure that you provide only high quality data input, but also to make sure that the system is sort of constrained so that it doesn't go off-piste, as it were. And I think you could put together a small language model, an SLM that is very targeted and entirely appropriate for the job at hand. In many domains, certainly in highly regulated domains, you want to be particularly careful, finance being a highly regulated domain, as is healthcare. And I think this is the way forward. If you're talking about, are these large language models the preserve of everyone, or are they just for the big firms? I think they are potentially for everyone. We're sort of exploring the limits of what is doable, as it were. And I think at a grassroots level, it is still expensive. I mean, you probably need a few $1 million to develop a reasonable small language model, shall we say, for finance. But I think it's very doable from that point of view. If you just want to take what others have created, so ChatGPT or a Gemini or a Llama, something like that, and then just use it and build in your guardrails at that layer via the API, then I think it's pretty much the preserve of anybody. It's incredibly cheap to sort of produce something like that. Now, how reliable that is and whether you wanted to actually release that into the wild is another matter. But if you were looking to fundraise, for example, if you wanted to sort of show people some sort of prototype, then why not? I think it's perfect from that point of view.
Yeah, no, that's very interesting. I mean, I've done a custom GPT in 15 minutes, and I've tried to feed it data, which I thought was good data, but the problem is it's very hard to restrict if you instruct it to use only that data, which is my good data, that good research paper, not the rest of the ETA. Now that you mentioned this, like small language model applied to a certain type of data, and then, customized to a particular application, there's really a lot of potential innovation, right? Because it's about developing applications. And that also brings another question, which I've discussed with Marco Abwab, my previous guest, who was also a hedge fund manager and dealt with hedge fund. It's something that surprised me. I thought data was kind of commoditized, especially financial data. He was describing it a little bit as picking the right fruit at the market, is finding the right data, finding the right provider. So it seems like not just the abundance of data, but the quality of data is a challenge and a big opportunity as well for someone who is in data.
Well, absolutely. If we talk about financial data, what type of data are we talking about? Are you saying you want closing market prices for liquid equities? That's easy, but
Yeah.
beneath the surface, there's a huge amount going on. I mean, there's an entire order book. There's tick by tick trading. So if you really want to get at what's going on, you need to elucidate the order book. You need to get hold of tick by tick data. You need to be able to analyze those data in the right way. A lot of people trade in the closing auction. Do you know what happens in the closing auction? Can you get at those data? Well, actually, the exchanges will sell you those data, quite pricey to get at that information. And no one is going to tell you what's right or wrong in terms of elucidating those data. It's up to you to sort of analyze it. And that's where us quants come in, because we're very good at coming up with seemingly plausible reasons for why certain models sort of work and others don't. Whether we're right or wrong, well, the proof is in the pudding, of course. If we build a trading model and then we sort of apply it, does it make money or not? It's very clear from that point of view. And I rather like that. And that's why I chose finance, because you have an immediate feedback in terms of what you've built. But no, I mean, hugely important, the sort of input. We're back to the input. So garbage in, garbage out. You need to make sure that you provide the right input and at the right scale. If I really want to know how something is traded, I want the ticks. Okay. And by the way, the ticks don't occur at precise, discretized moments in time. They're all over the place, of course. So, time is continuous, but models tend to be discrete. That's how we sort of describe them. So we've already got a mismatch. And then, of course, as a statistician, it would be wrong if I didn't sort of mention George Box's famous aphorism that all models are wrong, but some are useful. And that's as true now as it always has been.
No, that's really interesting in terms of the competitive landscape. So we understand, and maybe it's my simplified view, there's data, there's computing power, and there's models. And from what I gather, you can't really compete on the model, or at least have a sustainable advantage on the model side. So there will be more DeepSeek and things like that, but that means that now the kind of the standard will adapt, right? The efficiency.
Yeah, well, I mean, I think that is genuine human creativity. The attention mechanism is genuine creativity. We could come up with something else. Anything that cuts down on the amount of computation, any sort of shortcut is, hugely beneficial, potentially quite lucrative to the person that develops it. But, we tend to, us humans, and certainly when we're involved in industries, it tends to be more of the same, what works. Coming back to hedge fund strategies, convertible arbitrage seems to be working for a few people. Why don't I dive into that and try and do well myself? We tend to there's this sort of flocking behavior that goes on. And we're seeing that in terms of this emphasis on large language models and the desire for large companies to develop their own large language models.
So it's quite an optimistic output. Just the fact that DeepSeek originated from a hedge fund. So it's perhaps not surprising, right? Because hedge funds are the masters of data. Could we see more of that, more from the hedge fund space?
Well, I think, I can't remember the person who ran the hedge fund that sort of bankrolled DeepSeek. The first thing is that he bankrolled it. So you do need,
yes.
It is costly.
It's not 6 million. So I think there's a consensus that
so you need
a
few $1 million. If I'm going to do anything in the large language model space, I do need a few $1 million. So I need to bankroll that in some way. The second thing was, I think this hedge fund manager is particularly tech savvy. I think he's a scientist by training. I can't remember if he's an engineer or computer scientist. And so he sort of understands what's going on. I don't think it was sort of born out of a hedge fund as such. I think it was basically developed. It was almost a side hustle for that hedge fund. It's sort of, they had the resources to and the desire to develop some sort of large language model. I mean, absolutely fine. That type of work could be taking place in the university department somewhere. Watch this space. Let's see. Someone's bound to come up with something else, as it were. I see no harm in that. It is pretty egalitarian, right? It's the preserve of anyone. Literally.
Yeah, the question is more like, or if I was a hedge fund, could I build a company worth, I don't know, many billions, right?
Well, maybe. And actually, here's the other thing. Before you tell the world what you have developed, that you have a bit of a shortcut here, you make sure you sell short NVIDIA and all those other guys, because when I announce this, it's going to temporarily at least hurt their share price until people realize, well, actually, all you're going to do is incorporate that development in my own development, and it does nothing to demand. In fact, it probably fuels demand. So it's not hedge fund per se. It's basically, does the company have the resources to develop a large language model? And do they have the desire and understanding to develop that type of technology? It's not for everybody, of course. It doesn't have to be a hedge fund.
Yeah, sure.
I found it very amusing. I found the whole DeepSeek thing very amusing.
It is. So yeah, watch this space, as you said, might be coming from other places too. I think it's been a really fantastic reality check. We need it because we are all in this AI hype space, and eventually, yes, it's the binary model that is bringing us here. What is your outlook in terms of the application? I call it sometimes a fantasy fintech question in terms of what can be done if we don't have constraints, especially since you discuss it on a regular basis in your webinars, which is called the AI, even if we perhaps shouldn't use it this way, AI seminar for more technical audiences, which we're also going to link to the description of this podcast.
Okay, I mean, in terms of future development, I think I see probably it's quite phenomenal. Moore's law in terms of the number of transistors on a microchip is alive and well, and I can see that continuing. Although everyone says we're approaching the limits physically of what is possible there, we have such things known as analog chips that have graded response. We don't, that can do more than just compute in terms of zeros and ones. They're somewhat unreliable because obviously to get that range of output, you rely on solid state electronics, etc. And it's still sort of in its infancy. But the ability to compute in more than just on and off would be a major breakthrough. And then of course there's quantum computing, and there's a lot of hype around that. At the moment, we have sort of pseudo-quantum. We don't have true sort of quantum computing. There's evidence for quantum entanglement, but we haven't sort of harnessed that the behavior, as it were. But if quantum computing becomes a reality, there we are. Here's my sort of fantasy. Then all bets are off. Then everyone's security is broken immediately, etc. We've potentially got a real problem on our hands. Of course, we could use quantum computing to basically have quantum cryptography, in which case we can solve the problem that way. But yeah, there are some very interesting sort of computing developments. In terms of my background, I think there's always room for improvement in terms of basic mathematics. So we've got lots of nice routines for numerical analysis, and in fact everything we've spoken about in terms of model building hinges on the fact that I don't have analytic solutions. I need to solve these things numerically. And I think there's always room for improvement on that front. But we have some fantastic solutions from that point of view. Of course, a lot of these things go back to Cauchy and, even before then. So we're talking 19th century developments in terms of mathematics, in terms of what we have in our armory. People tend to forget or haven't been taught that we sort of rest on the shoulders of giants in terms of these fundamental principles that we rely on now to build our large language models, etc.
I think that's been a wonderful conversation, and it's really what I wanted to do. And I think it's been very clear when we think about innovation and things like that, well, like you said, there's no spark of genius. This AI is a different... It's also wonderful to consider how technology, even if it's not what we imagine it is, has brought us to, yes, this wonderful application. And the same with quantum. If Q-Day is happening anytime soon.
Certainly in terms of our current setup, binary computing, I do not see how there can, there will suddenly be, we'll achieve the singularity. I don't see artificial general intelligence in terms of binary computing. It is quite phenomenal what we can do, the sort of mimicry that is there at this stage. But yeah, I don't see a ghost in the machine. We will still be in control. We can turn it off. Now, at a quantum level, I don't know if we get quantum computing working, will we even understand the answers that are being given to us? But again, we'll only have ourselves to blame if we build a quantum computer that decides to sort of take over the world. We will have had to build it and have had to allow it free rein in order to sort of do it to us. So, I think there's an awful lot of scaremongering going on.
Amazing. You've answered so many questions, Richard. I'm so grateful for you. And now you're opened up with so many others. So that leaves us a lot to consider. But it's been great. Thank you so much. And we'll make sure to put all the links related to your work in the description, and to make sure that people can find you. And they can also ask questions by commenting on this video. And we'll make sure to answer. Thank you so much.
Brilliant. Thank you, George. It's been a pleasure to be here.